You know that highly specific kind of rage when you're just walking down the street. Maybe you're rushing to catch a train and you're trying to type a quick message with one hand.
Oh, yeah. The one-handed swipe of desperation.
Right. You swipe your thumb across the screen and the geometry of your movement is just absolutely perfect. You know exactly what you wrote, and then you look down.
And your phone has decided to interpret your heartfelt message as absolute gibberish.
Exactly. You try to write, "I'll be there in 5," and the screen confidently displays, "It'll be these in fine," and you just stare at it. I mean, it's the universal frustration of the modern era.
It really is.
We are walking around with these devices in our pockets that are powerful enough to calculate orbital mechanics or render 3D worlds, yet they still can't figure out that I virtually never talk about ducks when I'm angry.
It is the great paradox of mobile computing. We have supercomputer hardware, but the primary way we input text, the keyboard, is still operating on logic from basically 2010. It's the dumb mistake of modern autocorrect.
Well, today, we're digging into a project that claims to finally solve this. And we aren't just talking about a better spell check or some new colorful theme. We're doing a deep dive into a project called the Android Smart Keyboard.
This is a fascinating one because it represents a fundamental architectural shift. We are moving from geometry and probability, which is how your keyboard works right now, to actual intelligence.
We are talking about cramming a large language model, an LLM, the exact same kind of brain behind things like ChatGPT, directly into a smartphone keyboard.
Specifically into a mid-range smartphone. The mission here is incredibly ambitious. How do developers take that level of sentence-aware intelligence and run it on a phone without melting the processor or draining the battery in 45 minutes?
That is the big question. We have a stack of technical documentation here on a specific implementation targeting the Honor 200 Elite. So in this deep dive, we're going to tear apart the hardware challenges. We'll look at this really clever concept of a hybrid brain architecture and the surprisingly meta way they built the software using AI coding agents.
There is a lot to unpack, but to understand why this solution is a big deal, we first have to understand why the current tech is so bad. Like, why does my phone think hone is home?
Right. So let's set the scene. Most glide typing today uses something called n-gram dictionaries.
Correct. So an n-gram is essentially a sequence of items. In linguistics and computer science, it's a way of predicting the next item in a sequence based on the previous ones. But previous ones usually just means the last one or two words.
So it's looking at beads on a string.
Exactly. It's looking through a keyhole. It sees the word you just typed, and it checks a massive statistical table. It asks mathematically what word usually comes after them.
And it combines that with the shape you drew on the glass.
Right, the geometry. It tracks the path of your finger, the coordinates, and tries to match that squiggly line to a word in its dictionary that fits the statistical probability.
But here is the flaw. It doesn't actually know what I'm talking about.
It has zero semantic awareness. It relies purely on the probability of word pairs. It doesn't understand the meaning of the sentence. It's just math.
And that's where the Android Smart Keyboard completely flips the script. The innovation here is using an LLM to power that prediction. They call it sentence-aware glide typing.
This is the leap. Instead of just looking at the shape of the swipe and the last word, this system feeds the previous 10 to 15 words of your conversation into the model.
10 to 15 words. That's a huge difference. It's reading the room.
It's reading the context. It's deducing your intent based on the conversation so far.
The sources gave a perfect example of this that I think really clarifies the difference. It's the battle between home, whole, and hone. H-O-M-E, H-O-L-E, H-O-N-E.
This is the nightmare scenario for a standard keyboard. If you look at a QWERTY layout, the letters M, L, and N are all sitting right next to each other on the bottom row.
So if I swipe the word home, the geometric path my finger takes is almost identical to the path for hone.
Right. Geometrically, they are indistinguishable. So the old way, the enneagram way, has to guess. And it guesses based on frequency. People say I'm going home 1,000 times more often than they say I need to hone a skill. So the keyboard defaults to home.
Even if I just type the knife is dull, I need to...
Exactly. A standard keyboard sees to and home as a valid pair. It ignores the knife. But the Android Smart Keyboard, the LLM sees knife, dull, and need. It understands the context of sharpening.
So when I swipe that ambiguous shape, it overrides the geometry.
It prioritizes meaning over raw geometry. It knows you aren't going to home a knife, you are going to hone it.
That is the game changer. It's context over coordinates.
Yeah.
But okay, let's get real for a second. We're talking about LLMs here. These things are heavy. They usually run on massive server farms with liquid cooling. How on earth are they putting this on a mid-range phone?
That is where the engineering gets really interesting. The project brief specifically mentions the Honor 200 Elite as the test bed.
Let's look at the specs. We've got a MediaTek Dimensity 6080 chip, 8 GB of RAM, and a 4500 milliamp hour battery. That's a solid phone, but it's not a flagship supercomputer.
The 8 GB of RAM is actually the easy part. That's enough to hold a compressed model. The real enemy here is battery drain and heat.
Because if you ran a generative AI model every time I typed a single letter,
your battery would be dead before you finish the text message. It's incredibly computationally expensive. It's like firing up a jet engine just to go to the mailbox.
so they had to get clever. The documentation lists optimization strategy number 1, the trigger.
This is about discipline. They realized the AI doesn't need to be thinking constantly. If you were just tapping letters T, H, E, you don't need an LLM to know you're spelling this.
So the AI stays dormant.
Mostly. The system is designed to only trigger an inference. That's the AI doing the thinking on specific events. The most important one is glide complete.
Meaning when I lift my finger off the screen.
Right, that's the moment of ambiguity. You've traced a shape, and the system has to guess the word. That's when the AI wakes up, looks at the context, and solves the puzzle.
It also mentions triggering on a spacebar press or a 300 millisecond pause.
That pause is interesting. It's the writer's block trigger. If you stop typing for a third of a second, the AI assumes you're thinking about the next word, so it wakes up to offer a suggestion based on the conversation flow.
That triggers a really interesting thought about pacing. It's mimicking human cadence. But even with selected triggering, running a model is still hard on the processor. Which brings us to optimization strategy number 2. We have to talk about the chips.
The alphabet soup of hardware. We have the CPU, the GPU, and the NPU.
I think most of our listeners know the CPU is the main brain, and the GPU is, for graphics gamers, love their GPUs. Why are we using the GPU for this? It's powerful, right?
It is powerful, but it's designed for a different kind of work. GPUs are amazing at rendering 3D worlds, millions of pixels changing color in parallel. But running a GPU at full tilt requires a lot of juice. It generates heat.
So for a sustained task like typing, where you might be texting for 20 minutes straight,
A GPU would turn your phone into a hand warmer.
enter the NPU.
The neural processing unit. Think of the CPU as a general manager good at organizing everything. The GPU is an artist great at visuals. The NPU is a specialist accountant who is unbelievably fast at matrix multiplication.
Which is exactly the kind of math AI needs.
Precisely. NPUs are specialized hardware designed specifically for deep learning operations. They're far more efficient per watt. The project utilizes the MediaPipe API to access the NPU on that Dimensity chip.
So by offloading the thinking to the NPU, they keep the main CPU free for the operating system, and they keep the heat down.
And that is the only way you can make this viable on a consumer device. You have to use the right tool for the job.
Okay, so we have the hardware sorted. But the project sources describe this architecture as a hybrid brain. It's not just one AI, it's a tag team.
This is a very smart approach to balancing privacy and performance. The system uses a two-tier approach. Tier 1 is the local on-device AI. This is the primary workhorse.
And the model they're using is the Gemma 3 270M IT Litter. That is a mouthful.
It is. Let's break it down. It's a variant of Google's Gemma model family. The 270M refers to the parameter count 270 million.
Is that a lot?
In the world of LLMs, it's tiny. ChatGPT is in the trillions. Even small models usually run 7 or 8 billion parameters. 270 million is microscopic.
Why go so small?
To fit in the RAM and run fast. And they didn't just pick a small model, they used 8-bit quantization.
Explain that for us. What is quantization in this context?
Imagine you have a high-resolution photograph. It looks great, but the file size is huge. Quantization is like compressing that image. You lose a tiny bit of detail, maybe the edges aren't quite as sharp, but the file size drops dramatically. In AI terms, they compress the mathematical weights of the model so it fits into the memory and runs faster without losing too much of its smarts.
And what kind of speed are we seeing?
The notes say it runs at about 15 to 20 tokens per second on the Dimensity 6080. A token is roughly a word or part of a word.
That is faster than most people can read, let alone type.
Exactly. And the big benefit here is privacy. Since this Tier 1 model is local, your keystrokes never leave the device. It works offline. It's 100% private.
But it's a tiny model. 270 million parameters. I must get confused sometimes.
It does. It's not a genius. It's a smart assistant. That's where Tier 2 kicks in, the Cloud API fallback.
This is the hybrid part. The system calls for backup.
Right. The system monitors its own performance. The notes list 3 specific triggers for calling the cloud. First, if the local model lags, if latency goes over 300 milliseconds. Second, if the user specifically requests a smarter model.
And the third one really caught my eye. It switches to the cloud if the battery drops below 15%.
Yes.
That seems backwards to me. Doesn't using the radio to send data to the cloud use power? Why not stay local to save battery?
That's the counterintuitive part of modern mobile chips. Running the MPU at high intensity to crunch numbers actually burns more battery than just firing a tiny text string up to the cloud via Wi-Fi or 5G and waiting for an answer.
So it offloads the thinking to save the phone's life.
Exactly. It's outsourcing the heavy lifting when energy is scarce.
That is incredibly clever. And who are the cloud providers here? Who is doing the heavy lifting?
They built in options. There's Grok, which is known for ultra-low latency hardware, basically instant answers. There's Gemini Flash, which gives you that high-quality developer tier processing.
And for the privacy purists who still want power, there's support for Llama.
This is my favorite feature. Llama allows for private routing to a home PC.
So wait, walk me through that.
You install Llama on your desktop computer at home. Let's say you have a gaming rig with a big NVIDIA card. You can configure your phone so that when it needs Tier 2 help, it sends the data securely to your house.
So I could be sitting in a coffee shop, typing on my mid-range phone, and my gaming PC in the other room is doing the heavy lifting for my autocorrect.
It's the ultimate DIY option. You get the power of a massive model without giving your data to a big tech corporation.
I love that flexibility. So we've got the hardware, we've got the brain. Now let's talk about how they actually built this thing, because the development strategy section of the notes was really surprising. They didn't build a keyboard from scratch.
No, and they shouldn't. Building an input method service, that's the technical term for an Android keyboard, is notoriously tedious. There are thousands of edge cases, multi-touch, pop-ups, different languages.
So they faced the classic build versus buy dilemma.
And they chose option C, fork. They forked the AOSP Latinum. That's the Android open source project keyboard. It's the grandfather of the default keyboard on millions of devices.
Why use that old code?
Because it already contains the complex geometry math for detecting finger swipes. Calculating the path of a finger, normalizing the curve, mapping it to keys, that is complex trigonometry. Why write that from zero when Google has already perfected it in the open source code?
So they take the chassis of the old keyboard, but they'd swap out the engine. The notes call this the hook.
It's a surgical intervention. The developers identify a specific function in the AOSP code called suggest on device. In the original code, this function looks at the geometry and returns standard dictionary results.
So normally, suggest on device says, hey, based on this curve here is home, hole, and hone.
Exactly. But the developers intercepted that function. Instead of just returning those words to the user, the code takes those top 3 geometric matches, the candidates, and feeds them along with the previous sentence context into the Gemma model.
So the old code does the seeing, and the new AI does the choosing.
Perfectly put. The geometry narrows it down to the likely physical candidates, and the LLM picks the winner based on meaning. It's a brilliant way to combine deterministic math with probabilistic AI.
And they didn't even write all the glue code themselves. We have to talk about Google Joules.
Yes, the AI coding agent. We are seeing this more and more in software development. They use Google Joules to write the boring stuff.
The boilerplate. Android lifecycle code, XML layouts for the QWERTY setup, setting up the media pipe dependencies.
That's the stuff that takes hours but requires very little creativity. By handing that off to an AI agent, the human developers could focus on the hook and the optimization logic.
But they also use Joules as a critic. What does that mean?
It means they fed the error logs, the logcat, back into the AI. If the app crashed or had a memory leak, they asked Joules to analyze the log and suggest a fix.
It's like having a senior developer looking over your shoulder spotting memory leaks before they become a problem.
It accelerates the development cycle effectively. It allows a small team to build something that would have required a massive department just a few years ago.
It's so meta, using an AI to build an AI keyboard.
It really is. It's a case study in modern efficiency.
So let's zoom out a bit. We've gone from dumb geometry that thinks I'm talking about ducks to a context-aware AI running on a mid-range phone. We've got a hybrid brain that balances privacy and power.
And we have a development methodology that leverages open source legacy code and cutting-edge AI agents.
What stands out to you as the biggest takeaway here?
For me, it's the shift in the relationship between the user and the interface. For the last decade, we have been trained to accommodate our devices. We type carefully. We correct their mistakes. We limit our vocabulary because we know the phone won't get it.
We've been speaking keyboard instead of speaking English.
Exactly. This project represents a shift where the device starts to accommodate us. It stops guessing and starts understanding. It means you can be sloppy with your typing, you can use nuance, and the phone keeps up. And crucially, by doing it on device with the NPU, it proves we don't need to sacrifice our privacy to get that level of intelligence.
That is a powerful thought.
Eh,
It's technology finally working for us, not the other way around. And doing it efficiently. The fact that this is targeting the Honor 200 Lido standard consumer device shows that this isn't just for the ultra-premium flagship phones.
It is democratizing AI integration. You don't need a $1,000 phone to have a smart keyboard.
Here is where it gets really interesting for me, though, and this is something I want you, the listener, to think about.
Go on.
We've established that this keyboard is processing the last 15 words of context
Yeah.
to predict the next word. It knows what you are likely to say.
Right.
If the model gets good enough, at what point does the keyboard stop just correcting typos and start suggesting the content of your reply before you even formulate the thought?
That is the frontier.
I mean, if it knows I'm talking about dinner, and it knows who I'm talking to, and it knows my usual patterns, are we moving toward glide thinking, where I just vaguely swipe in the direction of an idea and the AI writes this sentence I should have thought of?
It blurs the line between assistance and authorship. If the AI predicts your intent better than you can articulate it, whose message is it really? Did you write it, or did you just approve it?
It's a subtle distinction, but a huge one. Are we communicating, or are we just curating suggestions from a machine?
That is a very provocative question.
Something to mull over the next time you're staring at those 3 predictive text options. Huge thanks to the developers pushing the boundaries on this, and thank you for tuning in to this deep dive.
Always a pleasure. Keep questioning the tech in your pocket.
See you next time.